Oh, gentlemen, I have got a treat especial for you guys. This is by far the most rare amplifier I've ever had come in my shop, by far. And the situation leading up to it coming here sucks. Just sucks. But it's here, and I've got my friend I need to take care of, and I've got my other friend that built this amplifier I have to honor, and all of you guys are gonna get to enjoy this. This is the most rare amplifier ever built, ever. This is the Gold Cup standard. This is the Gold Bar. This is the world-class WCW World Federation Championship heavyweight big dog on the street at the moment ever. This is the exclusive one of one built by Sharky, water-cooled 4-transistor MRFX 1K 80H. This is the first 4-transistor ldmos 65 volt water-cooled amplifier that has ever been built for 11 meter consumption. Those are a lot of big titles to live up to, right? I had to put these two in the same space. It's a lot of big words to describe this thing, and that's because it's true. The same big words could be said about this here. This is my 4 transistors. This uses the BLF 188XR. This was built significantly earlier than this. 2019. Okay. 4 years before this, I did the 50 volt part, the 188XR, but I did it in a cabinet ready for sale. All right. And then very quickly, within less than a month, I followed that up with 50 volt internal switched, ready to rock and roll, 12 volt DC to 50 volt DC internally rectified 1 transistor mobile. Then I built the 2 transistor mobile. Then I built the 2 transistor unit. All of these things have been done by my buddy Prime, and what I mean by that is not the 50 volt mobile bit, other than the internal switchers. Really, all this legacy leads back to Prime. I don't care what the other camps say. I have been waiting and waiting and waiting for, this is what, 10 years? 10 years for me to even see like a color Polaroid of something that predates the technology that I saw at Prime's place. Prime was the first one to do the 50 volt 4 transistor unit. He started in on his, and then I immediately started in on mine because I wanted to see if I could do it with him hand in hand. He has infinitely more money and way more ability to have cabinets made than I did, so I just grabbed a 32 transistor cabinet and by the magic of God made it all fit in this case. This is a 4,000 watt unit. This is an 8,000 watt unit. This is more towards a commercial standard. This is more towards the hobbyist standard, right? This amplifier here will produce easily 1,500 watts for 45 minutes continuous operation. This would turn into refried dog shit and turn into smoke before that time. Thank God most of us radio operators don't operate in a continuous duty cycle format. We operate more in a format that this box is built for. This is air-cooled, this is water-cooled. Prime's box was also air-cooled. It came first, this came within like a week after it. So, tomato, in my opinion, and I will always give credit to my good friend Prime, is number one, being the black Jesus of the radio community, and number two, really leading us forward into the future. And from this, we have seen a huge spawn of other people come up, try to build these amps. I have another one that's sitting around here that I got to go through here pretty quick that's from Gatekeeper that came out way after this. It's a 2 transistor device. We've got the amps that are getting imported. I'm not mentioning names because I don't want to do anything to anybody's anybody else's business, but there was a 4 transistor device that was recently here in town that was on its way to another place. These two are in the same place at the same time. The new one that's currently being produced and this one here, got to look at both technologies. I'd rather take this any day of the week. This isn't quite as finicky. The reason you don't see me building a lot with these, you guys, is because they are a little particular. I guess would be the best way to put it. If you have your head wrapped around how everything is supposed to operate and you keep yourself within that little window of operation space, it'd be drive power and voltages and whatnot, very reliable components. I mean, if you've ever heard me on the air, here, I'll give you another idea. If you have heard me on the air in the last 10 years, you have heard me talking to you through 2 BLF 188XR ldmos transistors as my driver. Fact. Now, my buddy Prime, okay, before I was cut off mid-sentence there because the battery died on the camera, I put this on my own station and operated it one time once, and it was way too much drive versus the amount of power I have coming in from my station. I thought I was going to blow something up on the street. Like I could hear the transformer out on the street going every time I keyed down. So I've never used this. I've toyed with the idea of selling it. It would have to go to just the right person though. And you'd be shocked what I let this go for. I put a post up in my Patreon group like what was this thing worth, and I got prices from $3,000 to absurd numbers, right? And you know, $4,500 or so, I'd probably let this go on to somebody else's house. I have no use for this, none whatsoever. It just sits here. But enough about this. Let's get this out of the way. I want to go talk about my good friend Sharky, the brilliant person that he is, and where he came from in my point of view, and where he has gone with this hobby, and how much it has helped drive others forward. So let me get this off the workbench and let's talk about this, because that's what we're all here to talk about. So there's been 2 of these produced. The second one is not an exact copy of this. I wasn't too sure if it had been assembled or not. When Sharky ordered the cabinet parts and had everything laser etched, he had enough parts made for 2 of these units. My friend Alex is the one that bought the OG unit number 1. I was talking with Sharky today on the phone about this thing here, and he divulged to me that the unit number 2 is in full. It has been fully completed and is hooked up and is tested and is running. He just hasn't bothered to put up his tower in over a year and doesn't care. He's got his mind full of other things. He's off having fun playing with cars and stuff. So this is the only one that's on the air at the moment. Sharky started out, he showed up in my world on my radar with a, if I remember correctly, a little 667 that he was having some problems with. And he was really into radio in California, and once he realized how crappy the design was that he was working with on that 667 and some of the failures that he had with it, he was off to the races. He is really smart. Like, he came to me, asked me some questions. I pointed him in the direction of where to go find knowledge, and he just took off. He didn't need me for anything. He went from a 667 to figuring out how to make a 1-pill work to a 4-pill transistor, and then directly into let's go play with ldmos, and then directly into let's start making kits, and then let's go build something that is more geared towards like a transmitter style of things. This thing is a beast. Okay, there's really no computer controls involved in this thing. If you want to run this thing until you blow it up, you're more than welcome to do it. There's no safety circuits in this because it's so overly built. Sharky has a whole video on the construction of this. We don't need to get into that today. We just don't. Now I want to be really clear. I can never, and nor would I ever, want to take any kind of credit for anything with Sharky. This guy is self-made like Henry Ford. You know what I'm saying? He also has a very good skill set of being able to explain complex problems by using simple words, right? So he did a huge series of very educational videos on how to make these, how to work with the parts, how transformers work, what we're actually talking about when it comes to tuning things. He had a whole gambit of subjects that he covered on his YouTube channel, and he is a very smart, self-taught individual. And I mean, I'm just grateful that I got to be around during the beginning, the height of education, and then him reaching this plateau, and then him deciding he wants to do other things, because he, let's face it, he's got a huge business. He's got a lot of people that depend on him. He's a very successful business owner, and he's very diversified in his fields of knowledge. And he just got tired of radio and went and did other things. Is doing things and having a lot of fun with it. So to be really clear, I got nothing but love and respect for my homeboy. Okay? All right. That all being said, if you can't tell, we hooked this up and we ran it last night. We charged it with water, and we went through the whole run process for this thing, which we're going to go over. The small problem that we have is, for some reason, the keying circuit doesn't want to work on this amplifier, and we don't know why. So we're going to look into that really quickly tonight and figure out what the problem is, and we're going to fix it. And then from there, we're going to get into the run it. And I'm here to tell you this thing runs exactly the way it did in his video. Verbatim to the watts, right? Just saying. He literally did a video where he keyed this thing for 45 minutes. And it's all because of the power of water. So this is a water / air-cooled amp. There are this many fans on the back. These are the exhaust vents that come out the front. This thing is designed to fit inside of a cabinet, like a server rack, which I think it would look really sexy if we put it inside of a server rack, but maybe whoever decides they want to buy it, because this thing is going to be up for sale, they'll let me put it inside of a server rack for them. I think that would be great. If not, it can come and it can get built right into a nice wood enclosure. I mean, it's got ears on it, and it's all set up to go right into a standard 1U wide server rack. So, okay, let me get this all disconnected, and we're going to pop it open. We're going to look at a couple different things, and I'm going to talk you through the logic process. Like I said, I called and I talked with Sharky today because I wanted to make sure, one, I had his consent to go stick my dick beaters inside of his beautiful baby. This is really something special. One, to be able to have this here. Two, to be able to shoot a video about it. And three, let's go figure out why the keying circuit isn't working. So, like I said, let me get this disconnected. I'm going to spend a little bit of time working with my student Tanner tonight, which I'm really excited because we're almost done with his little 4-pill transistor amplifier, and then I'll be back here and we'll be working on this. So, we've taken the side off the cabinet here. Can't help but admire this. We've seen this style of technology before. These are the pallets that were completely and totally designed by Sharky. This is his own personal design. All the parts were chosen by him. Each one of these boards were handmade by him. Like loaded, stuffed, assembled, and the whole 9 yards. This is all him, right? Even the output filtering choke, him. The combiner circuit that's over here, him. So the reason that my friend Alex brought me this is, one, he brought it to me just in case if there was any kind of problem, and two, he knew I'd know how to work on it if there was a problem, but there isn't, I don't think. So this is a tip 41C, okay, it's MOSFET. This is our jack for our keying circuit. Uses just a standard foot pedal pull to ground. This yellow wire, if we trace it over, comes to this tip 41C that's right here. So we have our gate voltage per se coming in, and then our output of our transistor comes over and it goes to our flow meter. The flow meter is a neat little bit of technology. It will keep you from putting the amplifier in transmit. This little box, there's a little reed switch that's on the inside of this hose, inside of this body movement, and if it doesn't have a sufficient amount of water to trip the switch, the amplifier can't key up. Now, this amp here, when you turn it on, that's your operating mode. This is full on, which means it puts it into transmit mode, which automatically locks everything. He told me today on the phone the reason why he designed that into the circuit was so that he could have himself the ability to trim all the bias settings, he thinks. Remember, it's been a minute since this has been built. But in the manual key mode, the amplifier doesn't do anything. The relays will not fire. So there's two things that can cause this. The FET being bad. Usually when they go bad, they're catastrophic, and flames and snot and things come forth from the gates of smoke released hell, and the magic smoke comes out of the parts. Or when we were dicking with this the other night, we didn't burp the system and there wasn't enough water flowing through to activate the reed switch. So the water path is real simple. It comes in from our chill reservoir. This is just a static column of water. Comes in from our chill reservoir. It goes through this pump that's right here, flows out, goes through our flow reservoir, comes up and goes through our chiller block. Please note, there's no heat sink here. This is all chiller block. Then the line proceeds to dump out, go through its first radiator. These are computer grade radiators, and that's the reason why there's, let's see, 2, 4, 6, 8 fans on the back of this thing. Comes out of that reservoir, comes up to this chill block. Out of this chill block, up to the next radiator. Comes out of the radiator, goes to the next chill block, comes out of that chill block and into the next radiator, which is up here. Out of this radiator, and then it returns to our water column. Now, I drained the water today, 2 reasons. I wanted to be able to show everybody how to go about charging the system, how to properly fill it, and for the next person that wants to operate it, they'll know how to actually properly set it up. The second reason is I wanted to flush it. This water looks a little bit like lemonade. It went in looking like this. Kind of came out this little bit slightly urine color. When we were flushing the system through yesterday, I noticed that there was a little bit of, well, leaven for the muffins. So you're going to need a funnel and about a gallon of distilled water. It doesn't take much to charge this system. Now I look at this entire thing and I go, that entire radiator block, that entire radiator block, that entire radiator block, that entire radiator block, all these chills plus all those lines, the chilling blocks, does not equal, plus the reservoir, does not equal the amount of water that we drained out of it. So what I wanted to do is I want to flush the system a couple times before I go and I start changing out any parts. I could come in here and probe it with the voltometer and very quickly determine if our switching FET has gone bad. This, when we pull this to ground, collapses the field on the FET and allows the relay to fire. So what we are going to do is I'm going to hook this up here in a minute. We're going to hook up the 65 volt power supply to it, and we're going to fill this and we're going to flush this a couple times because I want to make sure that we have properly burped the system. And in the process of doing that, then I get to demonstrate to all of you guys how we can go about actually setting this up. So the next owner of this piece of equipment can know how to properly operate it, maintain it, and run it themselves. It's about the best position that we're going to get. Okay, so it is very important that we don't use tap water. You never, ever, ever want to put tap water into the system or have it be exposed. Look, there's a lot of shit that's in tap water that's not good for this particular setup. Minerals being the number one, all the fluorides and chlorines and all the other crap that we put in our water. You don't want to introduce it into the system. You don't ever want it to be present. So there's this little thumb activated screw you can take out. You're going to take your funnel and very carefully, without any of the power supply or any other electronics, preferably a towel below you, Don't want anything to splash inside the amplifier, but you can very carefully, very smoothly, very calmly fill this up. And we're going to fill it up to this the white line on the black label on the front. That's cold. We're going to fill it up to about there. As soon as I flip this switch, I'm going to show this to you, this is going to suck down, way down. And that's us recharging the system. So here we go. Ready? 1, 2, 3. Now we shut that off again. Now we're going to recharge again. It's a little bit of a trick, because the water will keep leaking back up through the system. We're going to pull this down again. So now we've almost got it flushed through. Fill it up to full. Now we're going to turn the system down and just let it sit for a second. Put the pump running. Fill to the full line, and we're going to sit and we're going to wait. This is all air that's in the system. We got to wait for this to all percolate out and come through. Turn this off and we'll see the line comes way up. That's from air that's in the system displacing. So we can already see other crap that's come out of the system. When he put this in storage, my friend Alex, he drained everything. So this is just the remnants of whatever was sitting in the system. Distilled water is great because it's nothing but H2O, all the other fluoride, chlorines, all that other crap gone out of the system. Cycle it 2 or 3 times, and eventually all the bubbles will go away. See how we're seeing even less now? So the little pump's working great, but you can hear it's not running smoothly. Every time a bubble hits the impeller on the, you can hear it vibrating a little bit. So we about got her to our full line. We're going to screw our little cap back in. Now watch what happens. When this gets to be in balance, this line's not going to move maybe more than about that much. And we're right at almost the fill line. And as we start to displace the air out of the system, these are the bubbles that we're wanting to get rid of that will cause the flow meter not to trip properly. Just let this stabilize for a second. Let all the water come up out of the column, or all the air come up out of the column for the most part. Still getting an awful lot of air. See the air running right out of the copper. Only reason I know anything about this is because I had a water-cooled computer for a little while, which sucked. If a guy wanted to, he could get himself like a fish tank thermometer and put it on the side of this, the reed glass. That's what this is. So you could see your water temperature. Oh, so here's another big bubble out of the system. You have to change your water about every 6 to 8 months. In the heating process, nothing's perfectly sterile in this world, nothing. Life is ubiquitous on every square inch of this planet. Let's let this settle through some more. So all you got to do to drain it is the opposite of this process. Down here on the bottom is a thread-in check valve that you unscrew. Then you twist this valve and everything in this column will dump out, and then everything that's uphill, which is all the radiators, the chiller blocks, and all that stuff, will weep back through the pump and it'll fall out the bottom. So, more air. Eventually the bubbles will go away, and this will just become clear, static water. But the more bubbles we can get out of the system, the better this is going to work for us. This full line is an arbitrary mark. And where I came up with this mark, me personally, I put this mark on the amp because this isn't the way Sharky had it. This is for the next guy that has it. My friend Alex, he knew if the line of water was somewhere between these two marks, he knew he was good. And what I mean by marks is the actual residue that's on the inside of the pipe. This is technically halfway. We want to have a little bit of a room for an expansion at the top, and we don't want it so that when we turn the pump on, the water level falls below this nozzle and it starts pulling air into the system. Okay? So as long as you are within like an inch of this line in operation, you're safe, technically. You'll see it pulls right down to the full line, and now we see we don't have a lot of bubbles. Now the pump is an impeller driven pump, which is turning just a little bit too fast, and it's making a little bit of this thing called cavitation. It's where there's bubbles that form around the edge of a blade. Ask a submariner, he'll explain it all to you. I mean, their whole life revolves around if they're cavitating or not. Submariners know more about cavitation than any other person on the face of the earth. They'll tell you about it. Now, there's a little bit of cavitation going on, so you're going to see little tiny bubbles coming out of the drain pipe into the reservoir. We're not getting farts like out of Grandpa's ass dropping out of this thing anymore. So there's enough water in the system now. So it's got good circulation. We're not picking up any water from out of the radiators or any of the other lines. And like I said, it's a 3-position switch. When we go to that 3rd position, the amplifier goes into full transmit, and that's for an alignment procedure for the amplifier you don't ever need to worry about. So we've gone ahead and we've plugged our foot pedal in, have not changed a single thing on the amplifier. We could not get it to do that last night, and I don't think we'd properly burped the system. There wasn't enough fluid movement to make the interlock switch work. So I don't have to do anything to this, which makes me perfectly happy. Listen, Sharky's a genius, okay? Really is. He's smart. Smart mofo. I don't want to ever have to claim I did anything to this other than I looked at it, showed it to you guys on video. I'm not touching it. I don't want it, nothing. This box works amazing. It is fucking amazing. So, not have to modify anything on the inside. Makes my little boy nips hard. Okay, so if you're really interested in how this amplifier works, please feel free to go look up MudDuck Sharky 4-transistor ldmos amplifier on YouTube, and you will see the entire construction video of this. He shot his own video. He explains to you how every little bit of the circuitry that's in here works. All of it. How he put it together, how he came to the place where he was at with it, how he looked at all of his logic, everything. He did not dick around. Just saying. I don't want to take anything from him, and I'm not claiming nothing other than I'm just grateful that I get to be in here and I get to showcase this with you guys. Now that this is all working, and I'm happy, I'm going to put the side back on the amp, which no one will ever need to take off ever again. The only thing that makes me slightly in the smallest little bit sad is that nobody sprayed any of this with any clear. None of the inductor coils, none of this has got clear. The rest of it's gold plated because, well, it's gold. Doesn't corrode like ever. And I get to go put my tip, see, 41C back in its little storage container. And I don't have to change nothing in here. This makes me totally, totally, totally stoked. Let me put the side back on it. And we're going to talk about the back side of this thing, because he built into this another really, really cool function. This is honestly one of the nicest functions of this amplifier, are these two coax connectors right here. So our radio goes in here, our antenna attaches here, okay? Now what this allows us to do is to have this beautiful stuff here. This is a real honest to God embedded with a heatsink attenuator, built for a certain power level. Each device inside this amplifier requires a maximum of 5 watts worth of drive. I have said this screaming from the treetops. I have said this jumping up and down. I have almost set myself on fire trying to get you guys to listen. I famously have one story about an amplifier I built, and I put a 3-inch high sticker on the back that said no more than 100 watts peak drive. Another one that sits on the front says no more than 100 watts peak drive. The customer got the amplifier, and because the amplifier put out the same amount of power as an 8-pill, he hooked a Texas Star 350 to it and drove his Texas Star 350 into the amplifier and blew it up. Okay. Internally, I had an attenuator built into the amplifier like this. He wanted it to do more. This thing will not take more than 20 watts max drive, period, ever. Anything, the number one downfall to the ldmos transistor and all MOSFETs is drive. It's drive, okay? If you overdrive it, you're gonna pay a huge price because the parts will fail. If you don't overdrive it, the thing will last you forever. So don't be a fall down, smack your head against the table retard and fall within the rules. No overdrive. There's a nice sticker here that says 140 watts. Right on the back of this. Attenuator. 140 watts max through. Right on the back of it. So let's pay attention to the warning labels, okay? This attenuator is made by the JFW Industries Incorporated, Indianapolis, Indiana. The model number is 50 FHFR-600, or pardon me, 006-150N. So you guys that are trying to figure out how to build ldmos, this would be something very powerful for you to go peruse their products. It beats putting a resistor and then another resistor and then another resistor in line as your attenuator. We screw this into this loop. When the relay closes on the inside of the amplifier, the RF comes out this jack. It goes through the attenuator and goes back into the amplifier. Now, why do I admire this so much? Because you can change the attenuator. Instead of running your derail striker 655, 955, whatever, into this thing that makes 130, 140 watts, maybe you want to have a 25 or 30 watt or a 45 watt radio. Well, then with a little bit of math, help from me or Sharky, we can help you figure out which attenuator you need to put in this position to make it so you can never overdrive the amplifier, get to enjoy your modern or antique radio. Like, you could take your piece of Collins equipment and with the right attenuator, you could run it into this amplifier. Let that soak in for a minute. The fact that the attenuator circuit is interchangeable and this logic has been built into the amplifier at its time was a huge step forward. All right, let's run this thing. I want you to see how well this amplifier actually runs. This is literally going to be the easiest demo video I've ever shot. From every aspect. I don't have to tune or adjust anything on the amplifier. And also, we have a digital display. So let's show you our scales of measurement. That is a 5-watt element in reverse, back from the Bird 10,000 watt dummy load. This is obviously a 5,000 watt element in forward. And as we can all clearly, because I know that all of you guys have got driver's licenses and can read, it says average. And this is our 10,000 watt element in peak. Let me show you what we're going to put in this for drive. Let me back out. We're going to use our derail striker, bench radio. Hello. 137 to 140 watts peak envelope power, period. And about 45 bird is all we're going to put in this. Now I also want you guys to really keep into consideration that this amplifier would normally be sitting down on the floor or well away from you. And where I'm standing while I'm shooting this video, the mic is going to be about here. About 1 fist length away from the amplifier. So if you get the idea that this is loud, you are falsely mistaken. It is actually very quiet. Let's go over here before we jump into this. I'm going to move the camera forward a little bit. And let's go over here and let's get our FLIR started. Now, we'll go ahead and we'll put this into full transmit mode. And I'm looking for a rubber band. Rubber band? Where can I find me a rubber band? Here we go, rubber bands. And that rubber band broke. Might be time to buy me some new rubber bands. All right, so let's grab the microphone. We'll just hang it down here for now. Let's turn the mic gain back. And we'll run our carrier up. Remember, there's always a slight variance between the two elements, so we're just going to sit here and throw a 1500 watt carrier for a few minutes. Remember guys, we're water cooled. So this is 98 milliwatts, 100 milliwatts in return from our dummy load. The average meter is showing about 14. Our peak number is showing us about 17. Of course, there's a little bit more sensitivity. There could be a little bit of noise in the line, whatever, but we're roughly doing about 1500 watt carrier. Our FLIR has booted. And we'll come over here and we'll take a look at our chiller tube. The transistors right now, even though they're making 1500 watts of power, are getting in 77 degree water. 77 degrees. Water's going around in a big loop. Most of the work is being done by the exchangers in the back. This is just a buffer reservoir, right? 1500 watts of power. This is roughly about a 7,800 to 8,000 watt peak box, period. 8,000 watts out of 4 of these transistors as their peak numbers. Now, There are people out there right now that are working their little tail feathers off, building 16 and 24 versions of this, but they've been doing it for years. So I don't know if we'll ever actually get to see them or not, like if they're ever going to get done, but there are a lot of guys out there talking the talk and trying to walk the walk. Let's see if we got any temperature rise here yet in our water. So we're up to about 83 degrees, 84, somewhere in there. 83 at the bottom, the top, 84. Okay. Well within the danger zone. Well, I mean, well outside the danger zone, I mean. Sharky, when he demonstrated this thing running, he keyed it for, I think, 45 minutes at 1500 watts. This is as close to a continuous. Radio just timed out. This is close to a continuously rated amplifier that will ever be put into the market. This guy right here. I don't know. I mean, somebody might do something a little different down the road, but for right now, this is the only one in existence that we can have our hands laid upon. 86 degrees. I'm telling you, water is such a wonderful substrate for power transfer in certain applications. There is a whole lot of different goos that we can put in here now, but nobody's really tested them with RF, right? So somebody that owned a water-cooled amp like this, either be a water-cooled tube amplifier, or let's say a water-cooled MOSFET box, they've never gone and spent the money to invest in some of the very high dollar, don't ever need to replace, basically made from thinned down rubbing alcohol and glycol heat exchange medias. No one's ever tried it in an RF environment that I'm aware of. At least nobody in my circle, and my circle is vast and wide, and people talk to each other, right? I got to be able to move around, you guys, so I'm going to change your point of view. Let's zoom in here. I think my point has been proven. By the way, the input SWR in this amplifier is beyond ridiculously low. That's the 955 and reflect. Of course, the front of the 955 doesn't show us any input reflect, and that's because we're seeing the attenuator. The attenuator is only letting by exactly the amount of RF that the amplifier needs to operate. This is so impressive to me. Okay, so let's go ahead. We'll turn the radio up now. Turn the mic gain up on the radio. Hello, 1111, hello, 11111111. No problems there. Perfectly flat. Pass-through tunes the same way. So now, let's go down here and let's double check our voltage on our power supply. Now, me personally, I don't like to give any radio operator ever a variable voltage knob. Ever. I found that it has never worked out well for anybody on the face of the earth that is an amplifier builder. So I want to double check. The display on the front of the power supply says 64.3 volts. So now let's keep in mind, let's take this out of continuous. And now we're going to go to foot pedal activated. So now the bias is shut down. Before we go any further, let's really quickly here, let's check our water temperatures. '87 at the top of the tube, or the bottom of the tube, I mean. Still totally safe. Didn't cause any damage, never could cause any damage the way this is set up. So, hello, 1111, hello, 140 watts peak, 140 watts peak, not average, not bird, peak power. So if you're one of them, I only believe in bird numbers because I rebuke modern science, and you know, you're kind of watt meter Amish. I got it. Let's show you an average number. Hello. So no more than about 40 watts, 45 watts average. You know, bird watts, 45 bird average, no more than that. Going in. Hello. I feel very comfortable saying that this amplifier makes 7,000 to 800 watts peak and somewhere between 4,000 and 3,900 bird average going out. And that's with striker drive power. No other linears, none of that crap needed. This amplifier will work in all aspects. AM, FM, CW. FM, you want to back your power way down, by the way. So if we're seeing, let's say here's 7,000 watts, I probably wouldn't put more than about 1,500 watts out there on FM. Watch your water temperatures. FM's really hard on shit. That's why there's a different power. We back power down for FM. 11111. Okay. Hello. 1 2 1 2 audio. 111111. Hello. 111111. It will do this all day long. The same numbers will keep coming up over and over and over. Sharky pointed out to me that the variable voltage on the front of the amplifier could be abused if this isn't sold to the right person. And I agree with him. The power supply, which is sitting on the floor, which I haven't shown yet, but I'll show here in just a minute, has a variable power knob, like voltage a variable knob, and an amperage cutoff knob. The amperage cutoff knob we leave all the way up, and a variable voltage knob we leave at about 64 volts. We don't want to go to 65, 64. You can go higher, you can go to 70, but the amplifier is going to last 2 seconds, and it's going to be pretty obvious to us what happened. Oh, I hooked it up and it blew up right away. You don't know what you're talking about. This amp was in line for about 4 months, 5 months, talking every day, and then I showed up with a 3,000 for the guy, and well, this thing immediately got the water drained and it got set on the shelf. So it's been thoroughly tested by Sharky, the previous owner, and myself. If this thing gets blown up, the only reason you blew it up is because one, either you overdrove it, or two, you got yourself a happy knob and you started rubbing the nipples on the front of the power supply, and you took it someplace that you knew it wasn't safe, and that liability falls on you, so we don't want to hear it. Remember, these are ruggedized components. The 1K80H, you can cut the coax and still keep transmitting. The output SWR ratio does not, the amp does not care about that. So the only way this can get blown up is you turn the voltage up too high or you overdrive it. Both of those things fall on you. Those are your liability. So if you keep it within a reasonable spectrum, a reasonable realm of operation, hello 11111, hello 11 11111, hello 111111. The liability falls on you, but if you keep it within a reasonable level of operation, this thing will last you forever. Now look at what I finally got back in the mail today. My friends at Coaxial Dynamics built me a brand new 25 kW slug. This is 25 kW peak, by the way. I want to try it. I'm a little curious to see how far it is off. We've shown this does 7,000 to 8,000 watts peak. Why am I curious about how far my 25,000 watt directly from Coaxial Dynamics brand new element is? Well, the previous one was a little generous. And anybody that owns a 25,000 watt peak slug also would probably agree with me if they weren't in public and in front of their peers. You know, all their friends that know they use a 25,000 watt slug as their means of measurement, that their 25 kW element's usually a little generous by a couple thousand watts, conservatively speaking. I have seen them be off by like 10,000. So This is really, this element, they made these because, well, the CB community asked them to, and I don't think they take the calibration the way they do some of their other elements. But let's see if I've programmed in 25 kW into the digital meter yet. I have not. I've got 1K, 5K, 10K. So let's go here. Let's go to element. And then we're going to enter into this element. We're going to edit it. We're going to change our scale to 2.5. 25. Yeah, 250 kilowatt. That'll be hot. So we're going to set that for 25. We're going to say use. We're going to put that in use now. And we're going to back out. And so I can save that configuration. We're going to tell it to save. Yes. And then I never have to program this ever again. Boy, that was really simple, wasn't it? Man, a 2-year-old child with no reading ability in Botswana could figure this out. Okay, so let's put our 25 kW element in here. I'm kind of curious to see what we get out of this for numbers. Hello. 1111. I get to send it back, boys and girls. 1-1. It's obvious that the element is not picking anything up. Hello, 1111. Great. Good old coaxial dynamics. Yeah. Back to the 10K. Hello, 11. Hello, 1111. Hello, 11. Moving on. Okay, so what comes in this package? Well, if you live anywhere in the north or in the east, or even in a part of the south, you're going to get me to bring this thing to you, and I'm going to bring it to your front door. I'm going to bring it in your house. We're going to hook it up. We're going to set it up. I'll show you how to get the chiller system all set up, and you're going to get it installed by me. It also comes with a sequencer box. This requires a 12-volt power source. It comes with a plug for that. You have your radio input, amp input, and then your foot switch. This is designed so that it'll key your radio first, and then it keys the amplifier, and it's all driven from this input from this box. It comes with all the cables to make that work. It comes with the attenuator. It comes with a foot pedal. I think somewhere around here I've got a Heil trigger that goes with this thing as well. And it comes with the power supply, which is a separate unit. It's down here on the floor. In my conversation with Sharky today, I asked him, I said, dude, how did you come up with the number when you sold this thing? And he goes, well, I sold it based off what it was worth to me. He goes, Luke, after I added up all the custom machine work, all the bits and pieces that went inside of this thing, and at the time when it was produced, he goes, to me it was worth $10,000. His time, so forth. So that sets the benchmark standard for what the amplifier costs. If you were to try and call and beg and plead and say, Sharky, would you build me another one of these? You'd be looking at 10 grand. This is the only one in the world, other than the one he has, and he's got all the plans. He can make another one. I'm sure he's got some kits. I've got a kit of his sitting here. That's where this number comes from. The gentleman that bought this paid $10,000 for this unit. Now, is that what he's wanting to get out of it? No. He's asking around $9,000. So any serious number around 9,000, we're going to entertain it. And how that works out is it works out to be about $1.25 or $1.20 per watt, which is not too far of a cry from what it would cost you to get the equivalent in a solid state box today that isn't ldmos, that doesn't have all these fancy features, isn't water cooled. By the time you take into account the cost of the amplifier, the drive amplifiers, which would be 2, and the power supplies to run everything, the grand total will be roughly the same amount of money. This is completed, this is instant satisfaction, and by the way, this is way, way cooler. Like I said, now that I'm done with this video, I'm going to drain the system completely again. So when it gets to you on your side of the street, we're going to fill it up with distilled water. I'd really preferably like if I could deliver this. To box all this up and ship this across the United States is a little bit of a trick. Now, the guy that owns this has made it clear that if you're not in too big of a hurry timeline to receive it, he would also be willing to bring it to you. As long as you want to help him out. And the same thing with me, you're going to have to help me out a little bit with some fuel money and maybe a little bit of hotel room money. We'll come and we'll get this set up for you in your shack personally. So we're looking for around 9 grand. Any serious number that's around that, please don't hesitate to call, shoot me a text, reach out, whatever you got to do. Message me on Patreon, flipping send your buddy that lives here in town over here to ring my doorbell. I don't care. Reach out. Put out the energy, reach out, and we'll get you square. We'll make this happen for you. Honest to engine, this is a once-in-a-lifetime opportunity for somebody out there. This is a badass unit. If I couldn't build this myself, I'd probably keep it, but I can build this myself. I want to thank you, Sharky, for taking my phone call today. Thank you to my friend Alex for giving us the opportunity to revisit this technology and reaffirm that no, nobody else did this first. Okay. The ones that are currently being built, if they ever do get completed, I'm sure they will at some point, are amazing units. But right now, I mean, there's a gentleman that's building multiple units. They don't run like this, and nor are they water cooled. Power supplies are much bigger, much more cumbersome. There's not the flexibility built into them that we have here. Although they do have a fancy little display, and I'm not saying anything negative about them. I'm just saying that this is what it is. So if you're interested, please don't hesitate to reach out, give me a call, shoot me a text. I'll do what I can to help make your dreams come true. On that note, gentlemen, I just like to say this at the end of every video. Thank you to my Patreon supporters that allow me to spend multiple days dinking around with stuff like this. I think it's partially for their entertainment value, but, you know, thank you to my Patreon supporters down here. All you got to do is set up an account on Patreon and then come figure out how much you want to give as support to the channel. If I could set the tier system up at 50 cents a dollar and $1.50, I could, but the smallest they'll let me go is $1, $5, and $25. So show your support as needed, or as what you feel is necessary. They're also the ones that allow me to spend hours per day on the phone, and they are the reason that I can spend so much time editing and producing these videos versus working on physically getting the amps done. My production rate would be 3 or 4 times what it is if I wasn't doing these videos. So it's a trade-off, and I say thank you to the Patreon supporters for making this happen for all of us, by the way. Of course, none of this happens without all of you guys deciding that you're going to tune in and give me a thumbs up, leave a comment in the doobly-doo, any kind of interaction in the comment section. I don't care what it is. It helps with the algorithm. So I say thank you for all the comments. Appreciate all the thumbs up. Share this if you please. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck out here in Idaho, and it's been that way now for over a decade. I'm grateful that I get to be here, and I am so humbly thankful that this is my job. On that note, I appreciate every single one of you. I'm on to the next thing, and it is epically cool. I'll see you click, click.